All right, good morning, everyone. I'm hoping this is going to work out. I just upgraded to so it costs a little more money, but I think it'll be better quality. Happy September 1st to you. It's Tuesday. Weather's beautiful. We got some rain last night. It's all good. My garden is very happy this morning. Hey, this is what I wanted to share with you. Yesterday, we're having issues, meaning this. I should be able to take videos from YouTube and put them on here. And this was one of the videos that I wanted to show you yesterday, but unfortunately it didn't show. I guess it was being blocked through the OPS, like through your Gmail, because it's school related. We're working on this. So I wanted to share this with you. This kind of goes along with inductive reasoning, how you're using little pieces of evidence and you have to ask questions. And then sometimes when you're asking questions, you think that always you want to hear yes, that will help you to figure things out. But oftentimes it's the no's that will help you to come to the conclusion. So I'm going to show you this video. Hopefully you can hear it. I'm hoping we can hear it. I've got the volume on here. Let's see how this works. But I think this is maybe the route to get around this for right now, at least. So I'm going to play this video. Sit back, listen. As you can see, I'll share the rest of the screen with you about what I think is important in this little unit on inductive reasoning. So hope you enjoy this, and I'll be quiet right now.
I'm going to give you guys three numbers, a three-number sequence, and I have a rule in mind that these three numbers obey. And I want you to try to figure out what that rule is. But the way that you can get information is by proposing your own set of three numbers to which I will say, yes, that follows my rule, or no, it doesn't follow my rule, and then you can propose what you think the rule is. Is that fair?
Yeah.
Yeah, okay, so here are the three numbers, 2, 4, 8.
2, 4, 8.
You don't need to continue the sequence. You can propose a totally different sequence, whatever you want to propose, and I will simply say yes or no. That follows
2, 4, 8. 16, 32.
16, 32, and
64.
Those also follow my rule.
Okay.
What's the rule? What do you think?
Multiply by 2.
That is not my rule.
What?
That's not my rule. But you're allowed, if you want, propose three other numbers.
3, 6, 12.
3, 6, 12.
3, 6, 12 follows my rule.
10, 20, 40.
10, 20, 40.
That follows the rule.
Yeah, I'm still multiplying by 2.
I know. I know what you're doing. And yes, it follows my rule, but no, it's not my rule.
5, 10,
10 and 20.
Follows my rule.
100,
200, 400.
Follows my rule.
500, 1,000, 2,000.
Follows my rule.
Want me to keep going?
But do I just keep going? You didn't tell me your rule.
Am I doing it the wrong way? Am I approaching this the wrong way?
You're totally fine, but you're approaching it the way most people approach it. Like, think strategically about this. You want information.
Yeah.
I have information. The point of the three numbers, right, is to allow you to figure out what the rule is.
Yeah. Okay.
Okay, I'm going to give you the numbers that I don't think fits the sequence and then see what you say. So I'll say 2, 4, 7.
Fits my rule.
So whatever I propose is right.
So is your rule like you can propose any number?
So the rule is anything we say is yes.
No.
But you are on the right track now. Hit me with three numbers.
3, 6, 9.
Follows my rule.
Oh, that didn't follow my rule.
This is good, right?
5, 10, 15.
That follows my rule.
What? Oh. Really?
Yeah.
I don't believe you.
1, 2, 3.
1, 2, 3.
Follows the rule.
What about 7, 8, 9?
Follows. Yes, that follows the rule.
8, 16, 39.
Fits the rule.
Excellent.
But we're no closer to the rule. I want you to get to the rule. How about 1, 7, 13? Follows the rule.
What?
11, 12, 13.
How does this
Follows the
make
rule.
sense?
10,
I don't know
9,
how to
8.
do this.
Does not follow the rule. 10, 9, 8 does not.
Oh, so is it all in ascending order?
Booyah.
Okay.
Up top. Yes, first ones to get it. You guys nailed it. That's the rule. That's the rule. Increase numbers in increasing order.
Oh.
Numbers in ascending order. 1, 2, 3, 4, 5, 6, 10, 15, 25. Doesn't matter. Any numbers in ascending order. I was inspired to make this video by the book The Black Swan by Nassim Taleb. Now, the black swan is a metaphor for the unknown and the unexpected. I mean, in the old world, the theory was that all swans were white. So each instance of a white swan would make you think, yeah, that theory's pretty good. But the point is, you can never prove a theory true. And in fact, when people found Australia, they realized that there were black swans. What was interesting for me was that everyone I spoke to came up with a rule very early on and then only proposed numbers that fit with that rule they were thinking. I was looking for you guys to propose a set of numbers that didn't follow your rule and didn't follow my rule. I was looking for you guys not to try to confirm what you believe. You're always asking something where you expect the answer to be yes, right? Like you're trying to get at it.
But instead you want to get the no.
You want to get the no because that's much more informational for you than the yes. Like if everything's
No,
doing
that
a
is
yes.
true. That is really true once you say that.
That is what's so important about the scientific method. We set out to disprove our theories. And it's when we can't disprove them that we say, this must be getting at something really true about our reality. So I think we should do that in all aspects of our lives. If you think that something is true, you should try as hard as you can to disprove it. Only then can you really get at the truth and not fool yourself.
All right, good. So I'm glad everybody was able to see that. I'm banking you're being able to see that. So this was on inductive reasoning. As you know, I want you to continue reading the rest of this, as you did probably last night for homework. You had section 1.2 and 1.3. The other one was scientific theory, I believe. Now, I think you guys also realize once you get down here, okay, there's the practice. So you do the practice, okay. So whatever, preview, I guess, or something. But you guys will actually have the practice, and it goes through and tells you how to do it. You got to get 10 right. The questions will get harder or easier based on your progress. And then there's a little help if you need it. And then you start your practice, which is the final example of deductive reasoning. All the girls I know like the color pink, so all girls must like pink. 10 books are heavy, so all books must be heavy. Every dog that I've seen is black, so all the dogs must be black. Dogs are animals with fur, so my cousin's dog has fur. Just choose one. You got it, and it's correct. And then you will move to the next question. And you do for all 10 questions, and I shouldn't say all 10 questions. Once you get 10 correct, it'll ask you if you want to continue practicing, which you may, or you will be finished. And then at the top, there'll be a button up here that'll say, I believe, turn in. So you click turn in, but then you have to go back to your Google Classroom where it was posted and mark, mark it done, I believe. I think you submit it, or you mark it done and then submit. And then I will get your score, if that makes any sense. I will get your score. I can do another video about that whole thing if you need me to. All right. So yeah, I'm where am I? Stop for now. I'm going to stop for now. So it submits the practice, but I wouldn't want to submit that because I only had one correct. So I'm going to close this off. Okay. So you saw the video. The other unit you had was scientific theory, which hopefully you went through. And this is just talking about scientific theory. It's a broad explanation. It's generally widely accepted, and it's going to be supported by lots of evidence. But remember, it's very, very broad. So it can explain many observations to try to connect different phenomena that happen in the world. And they go through here, and you can read this about Dalton's atomic theory in terms of atoms and the different elements that compose all living everything living and non-living. And then they go through this, and I'll let you read this on your own. And I've highlighted what I think really are the key points. There's a lot of, nice to knows, but I think that the key is that the simpler the theory, the more likely it's to be correct. So you want to keep it kind of easy, not many pieces to it, just one piece. And it goes through this. And then you're going to practice and do just like before. And this is how you get credit. So please understand, the way you get credit is when you do the practice, you get the 10 correct, you turn it in, you mark it down on Google Classroom, you get credit for it. Okay, now here's what you're doing today. Scientific law. Okay, so with scientific law, if you go through this, and I haven't even quite gone through this, I want to show you, all right, what a law is, okay? And I had some students go through this. This was several years ago, and go through one of many laws in science. And this is Newton's third law of motion, which is every action, there's equal and opposite reaction force. And I think you'll enjoy this. And I'm going to play this right now just because we know YouTube is currently blocked. And so you won't be able to see this. So I need to share it with you this way. So I think this is just a real cute video, and just enjoy. Okay, so let me pop this up. And these kids right now, just so you know, this is roughly 7 years ago. So these students are 2021. They are juniors in college. So you'll be amazed at how fast time goes by. But you can see that this is at Memorial Park. So this is in the background of Memorial Park. And this is Lucas Burris and then Hunter Holdcraft. Maybe you know some of these kids or their names or their siblings, or they live near you. He does a really cute job with this. So enjoy this video, and then we'll talk in a sec.
Hello, my classmates. I'm Lucas Burris, alongside Hunter Holdcraft, and we'll be doing Newton's laws of motion today. First law, inertia. An object in motion stays in motion in a continuous straight line unless another force acts upon it. An object at rest stays at rest unless another force acts upon it. For example, if we put Hunter on this merry-go-round, which is at rest, we put Hunter on here, both are at rest. But if I spin it, it doesn't go to rest, it doesn't stay at rest, it goes into motion, as you're doing right now. It's going into motion. So right now we have an object in motion. Now, so if an object is in motion, it's going to stay in motion unless another force acts upon it, such as myself. So, this object, along with Hunter, was at rest. Then I spun the object and it went to motion. And then I stopped the spinning object and it went back into rest. So those are our laws of motion. This is Lucas Burris.
And I'm Hunter Holdcraft.
Signing out. Hello, my fellow classmates, and welcome back. I'm Lucas Burris alongside Hunter Holdcraft again. Now we're going to show you Newton's third law. Every action has an equal or opposite reaction, as we will show you now. We're going to have Hunter over here, and he's going to step on this basketball hoop, and then this water on this side of the basketball hoop is going to go flying over his head. Ready? Right. Hunter shall demonstrate. That was our action reaction. Our action was Hunter steps on the basketball hoop. Our reaction was the basketball hoop came flying up, the water went over Hunter's head, and the basketball hoop hit Hunter in the face. So thanks for joining us today. I'm Lucas Burris. That was Hunter Holdcraft. See you later.
All right. I absolutely love that. That's why I'm sharing that with you. All right. So we will get in Newton's laws of motion, but that'll be towards the end of the school year. But But I just wanted to kind of share with you one of the, a law, what a law is. And they give it to you down here. So it's just a statement. It describes what always happens under certain conditions. And then they list off a few different laws here. And this is why I thought this video is appropriate. It's humorous and appropriate at the same time, and entertaining. So here's something that's kind of really key here. And this, I would highlight what I've highlighted. So scientific laws state what always happen. Okay, so it's always going to happen under those certain conditions. They do have limitations, because here's what it is. It always will happen, but it doesn't explain why it happened. Okay, so the why questions are answered by theories, not by laws. So see if that makes sense to you. So there's the key difference. So laws state what will happen. So if this happens, then this will happen. But it doesn't explain the why. Why does that occur? Why for every action force there's an equal and opposite reaction force. That's a law, but it doesn't explain the why. Okay, so down here gives the summary. So after you've gone through and you've highlighted and read this, please complete this practice. Get your 10 correct and continue practicing if you want. Click the turn in button. It'll be up here at the top. And then you will go back into Teacher Ease and mark it complete and submit it. All right, so hopefully this has worked out well. Let's just see. Okay, now I've got to figure out, how do I stop this video? Oh, it's down here. All right.